We can do this substitution. When you go for substitution, if you can find one equation that you can solve for one variable in terms of another, and it's not going to look so bad, then that's a good way to go. Like in this equation, I could get y by itself, but I'll have like 3 things to attach to the y. If I go to my second equation and I solve for y, I add x to both sides, that's not such a bad little deal, right? So now I can take this and I could substitute this in, which I saw some of you do. The only thing, make sure you keep that negative sign. Just substitute it right into that. This is our substitution method. Okay, so we're going to distribute. Pull everything, you got descending variables, pull everything to one side and combine your like terms. Factor, your other favorite F word, factor, besides fractions. X is equal to 0, x minus 2 is equal to 0. So we've got 2 x's. Does that mean my point is 0, too? No. Every x point has a y coordinate with it. My parabola will cross 2 times, and I got to find its y value. Nice for us that this is already set up. Y equals. So I bring in my 0, and when x is 0, y is negative 1. I do the same for this side. I bring in my x is 2, or I already said y is 1, right? And I got y is 1 already, I guess. So here's my other point. You have 2 points. Now, a nice way to check this is using a graph. You already got this one solved for y, it's your line. When you come back up here, if you want to solve this guy for y, add y to that side and subtract 1. There's your parabola. You can graph this, and see that it in fact crosses at those 2 points. Another way to solve this is, see once you get your y's equal to each other, it's got to be the same y point. Just set those 2 equations equal to each other. Set them equal to each other. Get everything to one side. And you're back to where we left off here. We left off somewhere here. And then the rest works the same. So there's a number of ways to solve these algebraically. There's also elimination. Elimination, if you remember, you might have called it the addition method. In the addition method, if we can find a way to add these 2 equations down to eliminate a variable, it'll work for us. Now, what do you notice with these 2 if I add them down together? Can I eliminate a variable? These 2. If I add this down, this comes down, this becomes minus 2x, my y is eliminated, and I'm equal to 0. Oops, I'm back to where I was. Factor, stop. You remember the elimination? You'll probably recognize it in another one instead. This one's probably a little weird looking because you really have to make sure they're lined up and then you notice it. So we have a number of ways to solve these. In the next equation, this might look a little better for an elimination one. Does that remind you of elimination when they keep the x's together, the y's together, the numbers together? Kinda. Your goal when you do this is to eliminate one variable, whether you substitute in, whether you eliminate it, set the y's equal to each other. Now, if you take a look at this one for a second, let's eliminate some processes. If I want to do y equals, you're going to end up with fractions. And we know how you love fractions, so we're going to avoid that part. We're not going to do y equals. if we substitute out this equation, well, let me do this over here a second. So I've got a nice little equation. I subtract 2. I get an answer, right? Now, I can take this equation, I can multiply by 4. Every term by 4. Every term, including this one. I can solve it. Divide by 4. Oh, I get the same exact answer, right? So as long as I can eliminate, you know how you multiply by -1 and get rid of the negative? You have an equation. You can do whatever you want as long as it's to every term. If I want to, on this guy, do you see something that each one of these shares? A 2. If you want to, you can take a 2 out of here. Maybe. Do you see a variable you could solve for a little easier? X. So if I solve, this is my substitution, solve for x, and come back to this equation and substitute out the x for this guy. I can certainly solve that. Is it okay if I solve the y first and not the x? Sure. So I distribute 10y plus 35 plus 3y equals 9. I collect my like terms. I subtract 35 and I divide by 13 and I get my y. Now I don't have it nice because we already have an x equals set up. Do the same thing before. Every coordinate needs an xy pair. So I substitute in my -2 and I get -4 plus 7. So I get -4 plus 7, I get 3. And I have one solution. Now let me see if this makes sense. What actually is that an equation of, the first one and the second one? It'll give me a parabola, circle, a line, and the second one will give me a line, and the line can either cross 1, none, if they're parallel, or be the same line, infinity. So if obviously these were intersecting, and I only can get one solution if they intersect, right? So that's one way to do this. Now, another way to do this is your elimination process. Okay, it works for me. Okay, let's come over here. Once we do this, I bet you remember this. I'm just going to leave this without reducing it. You're going to look at your coefficients for your x and your y. You want them to be opposite signs so that when we add them together, if the coefficients are the same, they'll eliminate itself, right? So I kind of like that my y has a positive and negative, but I need them to be the same exact number. So what can I multiply this first equation by? I multiply this second equation by 4 and 3. So take the first common multiple that they have. They're both multiples of 12, right? And if you don't know where to start, you start with the larger number. Does 3 go into 4? No. Double it. 3 go into 8? No. Triple it. 3 go into 12? Ah. So if I multiply everybody here by 4, I get 20x plus 12y, and you got to multiply to 9, equals 36. I multiply everybody by 3. 6x minus 12y equals 42. Does that sound familiar now for elimination? When I add them together, out goes the y's. 26x is equal to 78. I divide by 26, and x is equal to 3. Ah, we did find x was equal to 3. Now I got to find my y. So the only problem is, it's not convenient, but I go back to either of my original problems, and I take this x and substitute it in, and I solve for y. Now, and you'll get your y would be equal to -2. The nice part about this one too is you can then take your answers and substitute it back into the last one to make sure it's checks. Remember how you checked it in the one that you didn't manipulate at all? Check it into that one. So we have an addition method, which is called elimination. We have a substitution method. If I could do y equals, that's another one, but I really don't want to have to deal with the fractions. Then you got to eliminate all your fractions along the way. We know how much you love fractions. So is this coming back to you? Okay. I want you guys to try the next one. First of all, what is the first one going to give me? We're going to solve for y2, just because we're going to just check Rebecca's work and see, in fact, if they don't intersect. We're going to add 2x, and we're going to divide by 4. Reduce that guy. And what do you notice about these lines? What is similar between this one and this one? The guy in front of x, what is that? The slope. They have the same slope. Same slopes with different y-intercepts. Those are parallel lines. They will never cross. Now, did anybody do an elimination or a substitution? What'd you do? You did both. Good. So how did you do your substitution? What'd you solve for? X. If you look at this, x is all by itself there. It makes a great substitution. Substitute for x, solve for x. X is equal to 2y plus 3. Substitute it into this x. This is your substitution. Negative 2 plus 2y plus 3. And it's okay if you solve for y first. It doesn't matter. Distribute. Out comes your 4y's. Is this a true statement? No. Therefore, no solution. If it's not a true statement, no solution. And we can tell by putting it in our y equals, that they're parallel lines. If you solve with elimination, line them up better than, of course I didn't for a reason, because I wanted you to be able to see it. Line them up. This is what you're looking at. These coefficients. You want them to be opposite signs and the same number. So I've got opposite signs. I'm looking at my x only because I didn't really need to look at my y's. If I multiply the top equation by what? 2. So let's multiply this guy by 2. 2x minus 4y equals 6. Bring this guy over. This comes out. This comes out. Oh, is this true? No. No solution. So it doesn't matter which way you go, you'll still find your no solution. Okay, you have one more to try. Try the last one. And let's see what would happen to these lines. 2x minus y equals 1. I'm going to add 1 and subtract 1 on this side. Okay, let's take this guy. You see, you can divide everybody by 2. You can just start with. Sometimes it's just easier. You're working with less numbers. They look a little bit different. Add y and, oops, 2x. Add y and subtract 1. They are the same exact line, aren't they? So I have infinite solutions for these guys. If you substituted, you might have solved for y, maybe. So you didn't have to deal with the fraction. You could solve for y in here as well and not get a fraction. So let's solve for y. So I'm going to add y and subtract 1, which we did up there. We're going to take this guy and substitute it into here. Whoops. Take that back. I'm going to substitute into y. Sorry about that. So we're going to 4x plus 2. These come out, and 2 is equal to 2. So if that's a true statement, then you have all solutions. You have infinite solutions. Negative infinity to positive infinity. You have infinite solutions. You don't have to check anything else. If you did your addition method, I noticed a couple of you were working on that. Again, look at your coefficients. They're both the same sign, so you're going to have to multiply one of them by a negative. So if you multiply, say, the top by a -2, I'll write it under here. Negative 4x plus 2y equals -2. When I add them down, 0 is equal to 0. That works too, right? So I have infinite solutions there. Now, if you take a look at the homework, which is right underneath where it's attached to your page, let me just show you one thing on the homework. Most of the time, it really doesn't matter which one you use, except when you get to number 64. I have, what is that an equation of, the first one? Circle. With the second one, a line. You don't want to do y equals y on these. You don't want to try to put that in your calculator because you've got to take the square root. And you're going to get a plus and a negative, which means you're going to have to do this twice. One for the positive part, one for the negative part. Because a line can cross a circle twice, once, or none. So the best way for this is a definite substitution. Solve for your y. And then substitute that into here. But don't forget to FOIL it. You got to FOIL it out. You just can't say squared squared, and you cannot take the square root of that equation. This you're going to have to pull over somewhere to the side and do 10x minus 2, and 10 minus 2x, 10 minus 2x. Okay? That's the only probably different one that you'll see in your homework. All right.